So here we're going to learn how to write and predict a chemical formula. And of course we have two different kinds of chemical formulas. One's called an empirical formula and the other is a molecular formula. The empirical formula is what we would call a simplified whole number ratio formula. So it is a very basic formula in which the subscripts of each element in the formula cannot be divisible by anything besides themselves and 1, meaning they can be further simplified. A molecular formula, on the other hand, can be simplified further. So it's not necessarily the most simplified whole number ratio. Another difference is that the empirical formula is a common formula. More than one compound can actually have the same empirical formula. It's sometimes actually a characteristic ratio of certain elements that would match a particular category of compounds, like simple sugars would have a 1 to 2 to 1 ratio of carbons, hydrogens, and oxygens. A molecular formula, however, is very, very specific, not general like the empirical formula. A particular molecular formula is specific for one compound and one compound only. Only when it's simplified can it be termed an empirical formula. How do we find an empirical formula? Most of the time we're given some percentages, as we have in this particular problem. Once we find the empirical formula, we can actually calculate the weight of the empirical formula, and then we can actually then, if we have the molecular weight, we can find the molecular formula as well. So we can go from very general to specific. So we're almost looking for clues here. The clues here are our percentages. So let's take a look at the percentages given. We have carbon as one component, that's 38.67%. We have hydrogen in the equation, and that is at 16.22%, and we also have some nitrogen in this compound, and that is at 45.11%, and we're asked to actually solve for the empirical formula. Now these are percentages, and in order to convert these percentages into units or moles, we need to actually have them be in grams. So rather than use percentages, we're going to assume these are grams, because if we add these grams together, they will make 100 grams. And if we had left them as percentages, they would have added up to 100%. So we're not just simply saying, let's make percentages grams because it's easy and that will get us on the way to finishing the problem and it's convenient, but rather we're using the ratio of 38.67 to 100 and 16.22 to 100 and 45.11 to 100 to our advantage, because if they were percentages, they'd add up to 100, and if they were grams, they'd add up to 100. So essentially, whether it's a percent, a gram, any other unit, the ratio of carbon amounts to 100, hydrogen amounts to 100, and nitrogen amounts to 100 are all the same. And that is not changing. So mathematically, what we're doing is acceptable. So the next thing we need to do is actually divide each of these by their atomic masses. So carbon's atomic mass is 12 grams. The atomic mass for hydrogen is 1 gram approximately, and nitrogen is 14 grams. So again, here we are dividing by the atomic mass. This will give us, of course, the number of units of each of these elements. How many carbons, how many hydrogens, how many nitrogens are in this empirical formula. So let's take a look and see. When we divide 38.67 by 12, we get 3.22. If we were to divide 16.22 by 1, we would get 16.22. And if we were to divide 45.11 by 14, we would also get 3.22. So these are the ratios. So essentially it's C 3.22, H 16.22, and 3.2 is our formula. Of course, we never have decimals or fractions in our formulas. They have to be whole number ratios. And in order to be empirical, they have to be simplified as well. These numbers are neither whole number nor simplified. So let's simplify them first. We'll simplify by dividing by the smallest one. So in this next step, divide by your smallest number. that will ensure that when you divide it by itself, and in this case the smallest number is 3.22, you will get 1. There's no number simpler than 1. So by dividing your values by the lowest number, you're assured to get the simplest values. So if we divide 1 by 3.22, we have to divide all of them by the same value, because all we're doing is we're simplifying. So make sure that you are consistent with that. So 16.22 divided by 3.22 is 5. And 3.22 divided by itself is 1. And again, when you get these numbers, they should be very close to 1, 5, and 1. You can round something that's a couple of hundredths away, 1.01, 1.02, 1.99 can be rounded to 2, for example, but you can't round anything, midway. You can't round 6.7 to 7 or round it down. It has to be very close, and if you have indeed followed these steps correctly, you will end up with a nice whole number value that you can round up relatively easily. Now that we have simplified to 1, 5, and 1, are they whole numbers? Yes, they are. So we have now a simplified whole number ratio. Our actual empirical formula then is C1 H5 and N1. So this is our empirical formula. Is it simplified? Yes, it is, because you can't divide anything by anything more than 1. And, of course, it is a whole number ratio. So the next question asks us to calculate the empirical weight. So what is the weight of this formula? So we have CH5N. 1 carbon is 12 grams. 5 hydrogens. It's 5 times 1, of course, is 5 grams. And 1 nitrogen is 14 grams. So I'm just using the atomic masses here. 1 carbon, each carbon is 12 grams on the periodic table. Hydrogen, each hydrogen is 1 gram on the periodic table. I have 5 of them, so 5 times 1 is how I got this 5 grams, if you're wondering. And 1 nitrogen is 14 grams. So if I add up 12 plus 5 plus 14, I end up with a total empirical weight of 31 grams. Alright, so now the last and final question, which is, alright, now that we've calculated the empirical formula and its mass, what would be the molecular formula if the molecular weight of this formula is 124 grams? Remember that the empirical formula is just simply a multiple, or a part of, I should say, the molecular formula. The molecular formula is the multiple of the empirical. So if we multiply the empirical formula by something, we would get the molecular formula. So how many times this small little empirical formula would make the molecular formula? By what factor should we multiply it to get the molecular formula? Because remember, this is simply a simplified version of this, but just how simplified? So if these two are ratios, the easiest way is to take the molecular weight and divide by the empirical weight. We're told the empirical weight is 124 grams. We've calculated the empirical weight up here ourselves at 31 grams. So 124 divided by 31 gives us 4. Alright, what that means is that our molecular formula weighs 4 times as much as our empirical formula. Where does that weight come from? The number of atoms. So if our weight is 4 times as much, then our number of atoms must be 4 times as much. And this whole empirical formula that we had as CH5N, we said times the question mark. The question mark we have found now is 4. Our formula weight was 4 times our empirical weight. Therefore, our molecular formula should be 4 times our empirical formula. C1 times 4 is C4. H5, 5 times 4 is 20. That's H20. 1n times 4 is 4. And this then would be our molecular formula. If we were simply to take a look at that, if I divide 4 into C4, I'd get 1 carbon. Divide 20 by 4, that would give me 5 hydrogens. And N by 4, that would give me N1. So it is a 1 to 5 to 1 ratio. 1 to 5 to 1. 1 to 5 to 1. There's a nice double checking. And if you wanted to go even further and take one more look and double check yourself, a nice easy way to do that is simply to do the following. And that is to take this formula that you've just determined, this molecular formula, and essentially calculate the formula weight, calculate the molecular weight, and see if you get this 124 that was given to you initially. If you've calculated the ratio of 4 right here to be correct, then you would have found the correct molecular weight, and therefore if I then took 4 carbons here and 20 hydrogens and 4 nitrogens, 4 times 12 would give me 48. 20 times 1, and again 12 is the atomic mass of carbon, 1 is the atomic mass of hydrogen, that's 20 grams. And I have 4 nitrogens, the atomic mass again on the periodic table is 14. So 4 times 14 would give us 56, if I'm not mistaken. And if I added 48 plus 20 plus 56, that would indeed give me 124 grams. So, yes, 124 grams is the molecular weight of this molecular formula, which when simplified goes back to our empirical formula. And how did we find that? Beginning with the percentage compositions, finding the empirical weight, and then finding the multiple of 4 here to help us calculate the final molecular formula.